This is Advanced Functions, Section 3.5, Dividing Polynomials. We're going to go over some vocabulary first. What you see here is a question that you might have done in elementary school, 16 over 5, right? And you would have converted it from an improper fraction to a mixed fraction. The first number on top here that we're dividing is called the dividend. Underneath it, we have the divisor, and our answer is the quotient with a remainder. So using those words, I've set up kind of an equation here, and it's important we know the terminology, the vocabulary. You will get questions frequently that ask you to, write, for example, isolate the dividend. I just want the dividend. So in this case, we would multiply each term by the word divisor, because if I were to isolate dividend, I've got to get rid of this denominator here. If you multiply each word by the word divisor, you would have this statement. The dividend is equal to the quotient times the divisor. That's from multiplying this by divisor. When I multiply this set by divisor, the denominator cancels and we just have remainder. So you just have some practice with making sure you understand how all of the different parts relate to each other, the vocabulary. We're going to do an example of long division. We've got a cubic here, and we're dividing it by a linear binomial. What will the degree of the quotient be? So the answer will have what degree? The answer for that, we would subtract the degrees of the highest power of each one, and we would get a 2, meaning you would have an x squared for within your first term. So let's actually do the division. So you're going to set it up like this. The divisor goes in the front and then the dividend under this operation symbol here. So the first thing I do is I divide the first part of the divisor into the first part of the dividend. So over here I'm going to write that down. I'm doing 3x cubed divided by x. So that would be 3x squared. Now that 3x squared, sometimes you'll see people put the x squared over the x squared. So I would write the 3x squared here so that it's over top of the 4x squared. It doesn't matter to me where you put it along that top operation symbol. So if you want to put it over if you want to just put it at the front, which is usually what I tend to do because I like to have lots of space, I just often put it right here. Okay, so the next step is we multiply that little piece of the quotient down with both parts of the divisor. So 3x squared times x is 3x cubed, and it should match if we did it right. That should be 3x cubed. And then 3x squared times 4 is 12x squared. So I'm going to subtract that piece. Now I'm going to put a big subtraction here because I want to remember I'm subtracting the whole thing. So sometimes if you want, you could put a bracket around this. You don't need to, but that just might remind you that everything's being subtracted. So 3x cubed minus 3x cubed is gone. 4x squared plus 12x squared, but we're subtracting that, right? That's why we have that big subtraction sign there. So it's actually subtract 12x squared, we get negative 8x squared. And that's our first piece done. So I'm going to switch colors. We need a binomial here, so I'm going to bring down this negative 2x, and I start it all over again. I take the first piece of the divisor, I divide it into the first piece of the dividend, so over here I'm going to write negative 8x squared divided by x. That's going to give me negative 8x. That goes up top in the quotient, negative 8x. Then I multiply this, as I did before, back into these two pieces of the divisor. That gives me negative 8x squared. It matches, of course, it's supposed to, minus 32x. Draw a line and subtract both terms on the bottom by both terms on the top. So these are gone. I now have negative 2x minus negative 32x. That's going to be 30x. And that's the second piece done. Now I need to bring down this constant, negative 1, and I'm going to divide again. I'm going to divide the first part of my divisor is going to be divided into the first part of, I guess, we could call this part of the dividend here. So we're dividing and we get 30x divided by x, and that's going to give me 30. That goes on the top, plus 30. It gets multiplied back into these two pieces. 30x plus 120. And I'm subtracting it. Remember, I'm subtracting the whole thing. Each piece gets subtracted. So the 30s, 30 minus 3x, they're gone. Negative 1 subtract 120 is negative 121. So I can't go any further. I don't have a binomial down here anymore. That's only part of it. But this is a constant. I can't take 121, negative 121, and divide it by x. So this part doesn't go, right? This is like your, when we had 16 over 5, and the answer was 3 whole, and whatever we had left over, remainder was 1 over 5. Didn't have a whole left there. So I'm going to write out my answer. The answer, let me just start by rewriting the question. Therefore, 3x cubed plus 4x squared minus 2x minus 1. When we divide that by, I'll put a bracket there, when we divide that polynomial by x plus 4, we get our quotient, which was this piece up here, 3x squared minus 8x plus 30. And then the remainder. Now I don't write the remainder just as minus 121. I can't write it like that because then technically these two pieces could have been put together, right? And it's not, it's a remainder of a portion. So I have to write it just as we did up here with the 1/5. We wouldn't write, I had 3 left over and then 1 more, because then that's actually 4. And we know 16 over 5 is not 4. So we have to write it properly, which is the remainder, which is 121 over the divisor x plus 4. So there's our answer to the first piece. So there's our first long division question, example 1. Example 2, again, we've got long division. We're going to divide, just set it up differently so you can see what it looks like, to determine the remainder. So the remainder is important this time. So we set up the question here, and we do it all again. This time I'm going to do it a little bit faster. If you like, I would suggest you press pause here. You do it all yourself. Actually, I've got to tell you something first before you press pause. If we look at this question right here, everything has to be in descending powers of x, which it is. We've got 5, 3, 2, 1, and then an x to the power of 0. But we're missing an x to the power of 4. So I had to put a placeholder in here for x to the power of 4, because if you can remember on our last question, we need things to line up so that we can subtract them. They have to be like terms. If I'm missing this piece, things won't line up. So anytime you're missing whatever your highest degree is, you have to make sure you've got everything else represented in this once you put it into the division operation here. So now that I've explained that, now you can press pause, do the question, or you can do it along with me if you like. So I start again dividing the first pieces together. That gives me 2x to the power of 4. I multiply it back down. That's 2x to the power of 5 minus 6x to the power of 4. And notice I have these x to the power of 4s lining up here because I put in that 0 placeholder. I subtract the whole thing, and all I'm left with is 6x to the power of 4. There's my first step. Switch colors, and I bring down negative x cubed here. Divide again. I'm going to put on top plus 6x to the power of 3. Multiply it back in, and I get 6x to the power of 4 minus 18x cubed. Subtract those pieces, and I have 17x cubed. That's the next piece. Let's bring down the 3x squared, and we divide again the first piece into the first piece, and we get 17x squared. Multiply it back. We have 17x cubed. Our numbers are getting a bit bigger, so minus 51x squared. Subtract. And I'm left with positive 54x squared. Bring down the negative 2x. Divide, and we have a 54x up here. Multiply it back in. That's 54x squared minus 162x, and subtract. This becomes addition, so that's 160x. Bring down the 7 plus 7. Divide one more time, and we get 160. That's 160x minus 480. Subtract all of that, and we're left with 487 for our remainder. And we can't go any further. The question says determine the remainder. So the remainder, therefore, the remainder is 487 over x minus 3. If you did that question on your own, I hope you got the same answer I did, but if not, just go through the steps. You probably made a mistake with, you didn't multiply something, or you forgot to subtract fully. That's kind of a common mistake there. The next thing you're going to see is a video that I found on Khan Academy that I think is great. So instead of hearing me explain everything all the time, I always encourage you to watch other videos. So let's watch a Khan Academy video, and you'll need to make your own notes.
In this expression, we're dividing this third-degree polynomial by this first-degree polynomial. And we could simplify this by using traditional algebraic long division. What we're going to cover in this video is a slightly different technique, and we call it synthetic division. And synthetic division is going to seem like a little bit of voodoo in the context of this video. And in the next few videos, we're going to think about why it actually makes sense, why you actually get the same result as traditional algebraic long division. My personal tastes are not to like synthetic division because it is very, very, very algorithmic. I prefer to do traditional algebraic long division, but I think you'll see that this has some advantages. It can be faster, and it also uses a lot less space on your paper. So let's actually perform this synthetic division. Let's actually simplify this expression. Before we start, there's two important things to keep in mind. We're doing kind of the most basic form of synthetic division. And to do this most basic algorithm, this most basic process, you have to look for two things in this bottom expression. The first is that it has to be a first degree, it has to be a polynomial of degree 1. So you have just an x here. You don't have an x squared, an x to the third, an x to the fourth, or anything like that. The other thing is that the coefficient here is a 1. There are ways to do it if the coefficient was different, but then our synthetic division will have to add a little bit of bells and whistles to it. So in general, what I'm going to show you now will work if you have something of the form x plus or minus something else. So with that said, let's actually perform the synthetic division. So the first thing I'm going to do is write all the coefficients for this polynomial that's in the numerator. So let's write all of them. So we have a 3, we have a 4, it's a positive 4, we have a negative 2, and a negative 1, and a negative 1. Then, and you'll see different people draw different types of signs here depending on how they're doing synthetic division, but this is the most traditional. And you want to leave some space right here for another row of numbers, so that's why I've gone all the way down here. And then we look at the denominator. And in particular, we're going to look whatever x plus or minus is right over here. So we'll look at, right over here we have a positive 4. Instead of writing a positive 4, we write the negative of that. So we write the negative of that, which would be negative 4. We write negative 4. And now we are all set up and we are ready to perform our synthetic division. It's going to seem like voodoo. In future videos, we'll explain why this works. So first, this first coefficient, we literally just bring it straight down. And so you put the 3 there. Then you multiply what you have here times the negative 4. So you multiply it times the negative 4. 3 times negative 4 is negative 12. Then you add the 4 to the negative 12. 4 plus negative 12 is negative 8. Then you multiply negative 8 times the negative 4. I think you see the pattern. Negative 8 times negative 4 is positive 32. Now we add negative 2 plus positive 32. That gives us positive 30. Then you multiply the positive 30 times the negative 4. And that gives you negative 120. Negative 120. And then you add the negative 1 plus the negative 120. And you end up with a negative 121. And now the last thing you do is you say, well, I have one term here, and in this plain vanilla simple version of synthetic division, we're only dealing actually when you have x plus or minus something, so you're only going to have one term there. So you separate out one term from the right, just like that, and we essentially have our answer, even though it seems like voodoo. So to simplify this, you get, and you can have a drum roll right over here. This is going to be, this right over here, this is going to be the constant term. You could think of it as a degree 0 term. This is going to be an x term, and this is going to be an x squared term. You can kind of just build up from here, saying this first one's going to be constant, then this is going to be an x term, then an x squared. If we had more, you'd have an x to the third, an x to the fourth, so on and so forth. So this is going to be equal to, 3x squared, minus 8x, plus 30, and this right over here you can view as the remainder. So minus 121 over the x plus 4. This didn't divide perfectly, so over the x plus 4. Another way you could have done it, you could have said this is the remainder, so I'm going to have a negative 121 over x plus 4, and it's going to be plus 30 minus 8x plus 3x squared. So hopefully that makes some sense. I'll do another example in the next video, and then we'll think about why this actually works. Let's do another synthetic division example. And in another video, we actually have the why this works relative to algebraic long division. But here it's going to be another, let's go through the process of it just so that you get comfortable with it. And now's a good chance to give it a shot, to actually try to simplify this rational expression. So let's think about this step by step. So the first thing I want to do is write all of the coefficients of the numerator. So I have a 2, I have a, oh, I have to be careful here, because the 2 is a coefficient for x to the 5th. I have no x to the 4th term. So for the x to the 4th term, I'm going to, let me start over. So I have the 2 from 2x to the 5th, and then I have no x to the 4th, so it's really 0x to the 4th. So I'll put a 0 as the coefficient for the x to the 4th term. And then I have a negative 1 times x to the 3rd, and then I have a positive 3 times x squared, positive 3 times x squared, negative 2 times x, negative 2 times x, and then I have a constant term or 0 degree term of 7. I just have a positive 7. And now let me just draw my little funky synthetic division operator looking symbol. And remember, the type of synthetic division we're doing, it only applies when we are dividing by an x plus or minus something. There's a slightly different process you would have to do if you had it, if it was 3x, or if it was negative 1x, or if it was 5x squared. This only works when we have x plus or minus something. In this case, we have x minus 3. So we have the negative 3 here. We have this negative 3. And the process we showed, there's other ways of doing it, is you take the negative of this. So the negative of negative 3 is positive 3. And now we're ready to perform our synthetic division. So we'll bring down this 2, and then multiply the 2 times 3. 2 times 3 gives us 6. 0 plus 6 is 6. And then we multiply that times the 3, and we get positive 18. Negative 1 plus 18 is 17. Multiply that times the 3. 17 times 3 is 51. 3 plus 51 is 54. Multiply that times 3. The numbers are getting kind of large now. So that's going to be what? 50 times 3 is 150. 4 times 3 is 12. So this is going to be 162. Negative 2 plus 162 is 160. 160. And then finally 160 times 3 is going to be 480. And you add 480 to 7, you get 487. And you can think of it, I only have one term or one number to the left-hand side of this bar here, or I'm just doing the standard traditional x plus or minus something version of long division, or synthetic division, I should say. So I can separate this out, and now I've essentially gotten my answer. And it looks like voodoo, and it kind of is voodoo. That's why I don't like to do it, because you're kind of just memorizing an algorithm. But there are other videos why we explain why, and it can be fast and convenient and paper saving very often, like you see right here. But then we have our final answer. It's going to be, and let me work backwards. So I'll start with our remainder. So our remainder is 487. 487. It's going to be 487 over x minus 3. 487 over x minus 3. And so this is our constant term. And so you're going to have plus 160 plus 487 over x minus 3. Now this is our x term. So it's going to be 54x. 54x plus all of this. This is going to be our x squared term. So this is going to be 17x squared plus 54x plus 160 and all of that. Then this is going to be our x to the third term. So this is going to be 6x to the third plus all of that. And then finally, this is our x to the fourth term. 2x to the fourth. And let me erase this because I don't want to. So then I have my x to the fourth term. So it is 2x to the fourth. And we are done. This thing simplifies to this right over here, and I encourage you to verify it with traditional algebraic long division.
So that previous example, if you didn't notice, was the example 2 that we did for long division. So they were both synthetic divisions that you already did were ones that I did first with long division, so you could see the difference, but also see that you're getting the same answer. Let's try one together here. Use synthetic division to calculate these two. So what we have to do first, I've set up my kind of operation symbol here for synthetic division. And I'm going to write the coefficients across the top part. So my first coefficient is a -2, but now notice that we're missing some stuff in between. We have an x to the power of 4 and x to the power of 2. We're missing the cube, so I'm going to have to put a 0 there for that placeholder. Then I go to the x to the power of 2, which is a 5. Then I go to the x, which is a -8, but I'm also missing the constant term, which is really x to the power of 0. So I'm going to have to put a 0 there. And over on the side, we put whatever would turn this little linear piece into 0. So when x is 2, I'd get 2 minus 2. So this is going to be a 2, which is also the opposite of what you see there. So our steps start here. Bring down the -2. That's a -2. And then we multiply. So this would be a good place to press pause and continue on. That's what I'm going to do. I'm going to press pause and I'm going to fill in the rest of the chart so this won't take so long. So we've got our remainder here on the other side of that line. This is our constant term, right? This is the constant term. Then this will be the x to the power of 1, x to the power of 2, and x cubed. These are the coefficients that go with all of those, so let's put them all together. And our answer is, I'll put it right up here at the top, the answer is negative 2x cubed minus 4x squared minus 3x minus 14, and we have a remainder, that's a negative, so I'm going to put a minus here, a remainder of 28, subtracting 28 over x minus 2. So I very much agree with Sal Khan in that synthetic division, I love it that he calls it voodoo. It's just these steps that you have memorized and you take, and these numbers are going all over the place, and there's your answer, right? You don't have a lot of understanding as to where this answer came from. Long division also has a lot of steps in multiplying division, but you're clearly seeing how these numbers are coming about as opposed to this one. But synthetic division is part of the curriculum, and it's important to know how to do, and it's a lot faster. It takes a lot less space, and you still get the right answer. It just doesn't work all the time. You need to make sure that your divisor is like in this kind of form here. So let's try one that's a little different when we have linear factors or when we have rational roots. So still synthetic division, but this one isn't set up. The other divisors were x plus 4, x plus 3, x minus 2, right? This time we have a 4. We have a coefficient in front of the x. So it's a factor. So if you see it written like this, that it's a factor, it means it will divide into, we're going to divide it into that, just like 2 is a factor of 8, for example. So we're still going to do division, synthetic division, to find the zeros. So this is a little bit more complicated of a question here. We've got some new steps that we haven't really talked about. For synthetic division, x must be isolated. Remember, this has supposed to be x plus 3, for example. It can't be like this. So I take my 4x plus 1, and I have to divide the 4 out. So I have x plus 1/4. Now I have a linear divisor here that I can use. So I set it up. There's my negative 1/4 here. Now I'm going to have to do all this work with fractions, which is a reason why I would never pick synthetic division for a question like this. Maybe I am not that great with fractions. Why do synthetic division? I would do long division. Question doesn't say to use synthetic, but I want to show you how we would use synthetic division for a question like this. So my coefficients all come, this doesn't change, the coefficients, the 8, it comes here, right? These are all the same terms that go at the beginning. So our next step, now we're just going to go ahead and start doing the synthetic division as we have before. So the 8 comes down. Now we have to do negative 1/4 times 8. Now that works out nice and evenly, so we don't have any extra fractions. Negative 1/4 times 8 is negative 2. And we add these. That's another bonus of synthetic, is you're adding instead, well, we will be doing 22 subtract 2, but we don't have to worry about another negative sign. That gives me a 20. Now I have to do 20 times negative 1/4. 20 times negative 1/4 is negative 5. So that gives me a negative 8 down here. Now I have to do negative 8 times negative 1/4. That's positive 2. And I have, my remainder is a 0. And I knew it was going to be a remainder. You didn't know that, but because it said it's a factor, that's kind of a clue that we're going to talk about later. But if it's a factor, it's, as I said, it's like 2 is a factor of 8. It goes evenly. So this, I knew this was going to happen here. I knew it was going to have a remainder of 0. So what have we got for our answer? Well, question said find the zeros. What have we got? We've got, the original question was 8x cubed. This was our polynomial, plus 22x squared minus 3x minus 2. That was our original polynomial, and that's equal to, so I'm going to take this, I divided by this part here, this linear factor 1/4. And when I did that, I was left with, now I'm going to turn this into a trinomial, 8x squared plus 20x minus 8, and we have no remainder. Now notice here, so when we factor, we don't leave our factors with fractions like we have here. But what commonly happens, of course, is I've got a greatest common factor in this piece here. So I'm trying to factor everything. This has a greatest common factor, and it is a 4. So I'm going to factor out that 4. I've got my x plus 1/4 here. Now I'm going to factor out the 4. I'm just going to squeeze it in the middle. Normally I'd bring it right to the front, but I just don't want to skip ahead there too fast. So there's my 4. That leaves me with 2. I'm factoring out a 4. 2x squared plus 5x minus 2. So let's take this 4 and just distribute it in here. Then we'll get rid of this ugly fraction. So I have 4x plus 1. We're back to our original, what we were given in the original question for a factor, and 2x squared. So this 4 just gets distributed into one bracket, not into both. Once you distribute it into here, you're done with it. Plus 5x minus 2. So are we done the question? No. The question said find the zeros. Find the zeros. So I need to continue to factor. And this is a trinomial. We're really comfortable with these trinomials. You could think about sum and product or a crisscross. What multiplies to -4 and adds to 5. Is there such a thing that does that? So think about that for a second. It seems like there should be, right? Those are numbers that you should be able to use a 4 and a 1 somehow to get it to work. But because of those signs, we can't. So what do you do when you can't factor, but you need zeros? You need roots. We can't factor this. So what are we going to do? Yes, I can hear you all shouting it into your computer. We're going to use a quadratic formula. Quadratic formula. That will give us the roots because that's what the question asked for. So quadratic formula, let me just write it up here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we sub it in. -5 plus or minus the square root of -5 squared minus 4 times 2 times -2 all over 2 times 2. So you finish all that. I'm just going to skip ahead because the video is long enough already. And let's go to the answer. This gives us a 0 at x equals -1/4. That's what we get from that bracket. The way I got that, if I lost you there, I took 4x plus 1. I made it equal to 0. Brought the 1 over. That gave me 4x equals -1 divided by 4. This one I couldn't, the second set of brackets, I couldn't factor. Remember, we couldn't factor that, so we use the quadratic formula. You do all the work there, and hopefully, sometimes I make mistakes in these videos or with my calculator. I'm sorry, just message me if I did, and I can go back and fix it. But this is what I've got here. I've got x equals, and we're going to use decimals because we use the quadratic formula, about -2.85. And we have a third one, x equals 0.35. So the original question was a cubic right here. This was a cubic, and we had to find the zeros. We were given one factor, right? We got one factor. We had to find the rest. We got 3 zeros, which is certainly possible with a cubic. This one has a positive leading coefficient, so we know the cubic has this shape. It's kind of going like that. So it would cross the x-axis 3 times. That's the last example for the lesson on division. So you've got synthetic division and long division. You have to be able to do both, but if the question doesn't tell you, you can pick the one you like best. Just make sure you're practicing both types of questions. there are some, if you have the handout, there are a few little pointers on the handout as well to make sure you read before you start your homework. Good luck.